So we are dealing with this electric circuit right now. We have two resistors in here. Let's call it R1 and R2. None of them are given. We need to find out both. V2 is given, which is 1.2 times 10 to the power of 2, which is going to be 120 volts. So since it's in parallel with this resistor and the total one, it means that V1 equals to V2 equals to V0. That's Kirchhoff's law. So since all of them are in parallel, it means that we have 120 volts. And in here we have total electric current is 15. So I'm gonna say the equivalent resistance is gonna be RT, which is V divided by I naught, or V naught divided by I naught. That will be 120 divided by 15. That's gonna give me 8 ohm. So now we have these two. None of them are given. Let's find out the I2. I1 is given. The total I is 15. So we know I naught equals to I1 plus I2 because it's going to branch out in here. I1 is given, which is 6. So we have 15 equals to 6 plus I2. Therefore, I2 is going to be 15 minus 6. That's going to be 9 ampere. So here we are dealing with then 9 ampere. After that, we need to find out R1 and R2. R2 is going to be V2 divided by I2, which is 120 divided by 9. That's going to give me 13.33. And on the other hand, we have R1, which is going to be V1 divided by I1. That case is going to be 120 divided by 6, which is going to be 20 ohm. Now we can check the equivalent resistance. Equivalent resistance is 1 over RT equals to 1 over R1 plus 1 over R2. That's going to be 1 over 13.33 plus 1 over 20. When you calculate it, 1 over 13.33 is going to be 0.075. 1 over 20 is going to be 0.05. When you add these two, it's going to give me 0.125. So 1 over RT is 0.125. RT will be 1 divided by 0.125. That's going to give me 8 ohm. Now we know everything. We know V0, we know V1, V2, I1, I2, and R1, R2.